Imagine you're trying to store data about a user, their name, their email, their address, maybe their profile picture URL. In a traditional database, you'd build a table, define every column up front, and every row has to fit that exact shape. That's fine, until your users start having different data. What if instead you could just store it exactly how it looks in your app, like a JavaScript object? That's MongoDB. And in this video, we're going to understand it from the ground up, how it thinks, how it's structured, how to manage it from the command line through a GUI, through the cloud, and how to actually talk to it from your Node.js code. Whether you've never touched a database or you're coming from SQL, this is the video. Open WebStorm. It is an application that we'll be using to do this project. It is basically an IDE for JavaScript created by IntelliJ. So we will create a brand new project and we will actually just create an empty project for this. I'll give my project a name, so MongoDB tutorial, and I'll create this project right here. Once this project has been created, you can use anything that you'd like. I'll just create a new JavaScript file so you can follow along in VS Code as well. But I'll create a new JavaScript file and I will name it concepts. So here we have our file. I'll zoom in a bit. So the first thing that we need to understand is what is actually MongoDB. So when you build an application, when you build your application, whether it's a mobile app, an API, a website, your app produces data. The data might be in the form of users, the data might be form of orders, or you might have posts, you might have messages. So you have different kinds of data that is produced by your application, no matter what you make. And all of this data needs to stay somewhere. It cannot just remain in temporary memory forever because it actually needs to be stored somewhere permanent. If it is in temporary memory, it just disappears the moment your server restarts. It needs to be in something called a live database. Now, when we talk about databases, there are two kinds of databases. There's relational databases and there is unstructured or non-relational databases. So in relational databases, you'll hear names like MySQL, Postgres, and SQLi. In unstructured, you'll hear names like MongoDB, Cassandra, Dynamo, etc. The most common one that we actually use in programming is relational databases. They store data in something called tables, and tables, as you know, have rows and columns like a spreadsheet. Every row has the same shape. So you'll see a structure like this. This is what a relational database would look like when it's storing data. So you have your table, then you have your columns, your different columns, then you would have your different columns, and you would have rows of information in that table. So in this case, we have a column for ID, name, email, and role, and we have two different rows for data. So the first row has Alice with his email and his role. The second row has Bob with his email and his role. But MongoDB is a different type of database. It's an unstructured database where instead of tables and rows like this, it stores data as documents. And those documents look exactly like JSON objects. If you've written any JavaScript, you've already written something that looks like a MongoDB document. This right here is what a MongoDB document would look like. It has fields. So it has name, it has email, it has role. And each of these fields have a value. So Rajan, the email, and the role admin. There's no rigid structure like this table right here enforced at the database level. Different documents, so different users like this, different objects, can have different fields, completely different fields. It does not need to be the same. So MongoDB is open source. MongoDB Inc. is an open source DB software. We have something called Atlas, which is our cloud-hosted managed MongoDB. It is what we'll be using today. So the cloud-hosted managed version where they run and manage the entire infrastructure for you is called Atlas. You can also download a local version called Compass where you can run the entire database locally. MongoDB is used in production by serious companies. So eBay, Coinbase, Forbes, Toyota, all of these companies are running at MongoDB. It's actually just battle tested, not a toy. Alright, that's the what. Now let's understand the key difference from SQL, and this is the mental shift that anybody coming from SQL needs to have before learning unstructured Mongo database. Let me show you the single most important mental shift when moving from SQL to MongoDB. Because if you've worked with relational databases before, your brain has been trained to think a certain way, and MongoDB asks you to think differently. Let's say we're building a user management system. What would you do in an SQL approach? In an SQL approach, you'd create a users table, and if the users have addresses, you'd create a separate addresses table. So to get a user with their address, you use join. And every single time you need a user and their address, you need to read two different tables and combine the query. In MongoDB, you just put it all in one document. The address actually just lives inside the user. This is called embedding. So I've embedded an object inside of another object. And it's one of MongoDB's core data modeling strategies. You embed data that is always used together. When you fetch a user, so when you fetch this user, you almost always fetch their address too. So why store them separately and pay the join cost every single time? Now let me type out the full terminology mapping because this actually trips people up. So let's look at our terminology map. So there's a few terms that are used differently as to how they would be used in a relational database or a SQL database. Hello. Okay. The first thing, database. Let's look at SQL and MongoDB. So the first thing is database to database. Is the same thing. Next, table is a table in SQL is a collection in MongoDB. A row is a document. A column is known as a field. Your primary key in SQL becomes the _ID field in MongoDB. MongoDB actually auto-generates this field and you never have to manage it. A join in SQL becomes either an embedded document, or if you need to reference across collections, a $lookup in MongoDB's aggregation pipeline. And then the big one, the schema. In SQL, the database enforces the schema. You define your columns upfront. You cannot store a value in a column that doesn't exist. In MongoDB, the schema is flexible. The database itself doesn't enforce it. Two documents in the same collection can have completely different fields. One important note though. Flexible schema does not mean no schema. In real applications, you define and validate your schema in the application layer by using Mongoose. But the database doesn't really care. That flexibility means that you can evolve your data model without running alter table migrations, which is a huge deal when you're running fast. It's much faster than SQL databases. What does MongoDB have an edge on? Well, when your data is hierarchical, like users with embedded orders, with embedded order items, when documents don't all look the same, when your schema is still evolving. When does SQL win? Well, when you have complex many-to-many relationships in all directions and data integrity is very important to you, like a financial system. Both are amazing tools. They both solve different problems. All right, now let me show you the full structure of MongoDB from top to bottom. MongoDB has a hierarchy of 5 different levels. Once you understand this, you'll always know exactly where your data lives. Let's look at it top to bottom. So level 1 is your cluster. This is your MongoDB server. This is the top level container for everything. In Atlas, when you spin up a free M0 instance, that's your cluster. Locally, when you run MongoD, that's your cluster. One cluster can contain multiple different databases. Then in level 2, we have our databases. Inside a cluster, you have different databases. Typically, you have one per application. And in level 3, you have collections. Inside a database are collections. So on the top, you have a cluster. One cluster can have multiple different databases. Each database is typically used for one application. Inside a database, you have something called a collection. So all of users, orders, and products get their own collections. It's the MongoDB's equivalent for a table in structured language. Users go inside the user collections, orders go inside the order collection, and products go inside the product collection. Finally, we have our final layer, which is documents, level 4. So inside a collection, you can have multiple documents. Let's look at these 3 documents. Document 1, Document 2, and Document 3. Let me zoom out slightly. What difference do you notice between these three documents? Well, Alice doesn't have a phone number. It only has 4 fields. Bob doesn't have any tags, and Priya doesn't really have a role. They all have ID, name, and email fields, but beyond that, they're free to be different. That's flexible schema in action that you cannot really achieve with a structured database. And finally, we have fields. So inside a document, every key pair value is a field. So inside this document, the key pair value name and Priya is a field. The ID and object ID is a field, and tags and this array are also a field. There's different kinds of fields, but every document gets this ID field. It's automatically generated as an object ID, something called an object ID. It is actually a 24-character text string. The first 8 characters encode the timestamp, which means object IDs are roughly sortable by when they're created. The rest encodes machine, process, and a random counter to guarantee uniqueness. You'll deal with object IDs constantly. Whenever you fetch or update a specific document, you will refer to its object ID. So if I want to fetch this specific document, I would refer to this object ID, which would give me document 3, which has the fields name, email, tags, and verified. This document in turn lives inside the collection, which is users. Users lives inside the database, which is users app, and the database lives inside a cluster. Let's look at an example document to see all the data types that you might use. The first is your standard string data type. Then you can use a number, which will get a number data type. You can have Boolean values with a Boolean data type. You can have arrays stored inside keys. You can have embedded documents, so different documents inside. You can have dates, so you can use ISO date of JavaScript. Then you have your object ID that we discussed earlier, and you can have your null data type. So in the end, we have 5 levels. The first level is your cluster. Then you have your collection. The first level is your cluster. Then you have your databases. You have collections inside databases and documents inside that collection. In your documents, you have different fields that can hold different data types of values that you will use. So that is the entire structural model of MongoDB. Everything you'll do in Compass, in mongosh, which is the shell editor for MongoDB, in your Node.js code, it's all navigating this hierarchy and operating on these documents that are stored inside it. Now let's actually spin this up and get our hands on a real database. Okay, we're going to set up 2 things in this section. First, we'll set up a free cloud-hosted cluster on MongoDB Atlas. Second, I'll briefly show you the local install path for those of you who prefer to do everything on your own machine. For the rest of this video, we'll use Atlas because the connection string works identically whether your database is in the cloud or localhost. So first of all, I'd like to search MongoDB Atlas. After searching MongoDB Atlas, let's scroll down a little bit here and go to our Atlas database. On the top right here, click on Get Started and sign up with your Google. After you signed into your Google account, you might get this page. So this is the very beginning. Our primary goal, let's just say learn MongoDB. How long? I've never developed with MongoDB before. Our primary language for me, well, it's going to be JavaScript. What types of data will your project use? So we don't really need to select this. Just click on Other. And will your applications include any of the following architectural models? So not sure. And let's finish this. You can skip the entire personalization part, but filling it out doesn't have a downside either. As soon as you do this, you'll be directed to this page. So on this page is where we'll create our cluster. So cluster is the level 1, the top level. And up here, you'll see M10 cluster, flex cluster, and free cluster. For our purposes, we'll be using the free cluster. It is free forever, you don't need credit cards, and we'll name it. And provider, you can just select any that you'd like. I recommend using a provider that's closer to you, and of course, eco-friendly is always an upside. After you do all of this, click on Create Deployment by leaving everything on default. So right now, your cluster is going to be created. While it's being created, you'll get a prompt asking for your username and password to set up your database user. Now, this is very important. This is the username and password that your application will use to connect to your database. So pick a username. For the password, either type generate, so either use the generated one, or you can set your own password. So I'll use this password. I've simply copied the password and copied the username. Click on Create Database User. After you clicked on Create Database User, go to choose a connection method. For this, currently we haven't set up everything yet, so we'll just click Close out of this. So close all of the extra menus that you get, and I want you to go to the left, Project Identity and Access. Open up Compass if you haven't opened it up yet, and if you've not installed it, then you should definitely have done it by now. So once you open your Compass, it's the MongoDB's official desktop GUI. It lets you visually browse your data, run queries, analyze your schema, and manage collections. You don't actually have to write a single line of code inside it. It's brilliant for exploring data, debugging issues, and onboarding non-technical teammates. So once you open your Compass, you probably won't see exactly what I'm seeing, but if you do see this, then you'll have a button called Add New Connection. Click on Add New Connection. In your URI, you'll have a default connection, so if you're using your local database, then go for it. But since we had a cluster database, I will be adding the connection string of my cluster that we copied earlier. This was the database connection string that we got earlier, and in place of the database, I replaced it with the password of my database. In the name, I'll just leave it as Learn MongoDB and ignore everything else. For color, well, you can give a color. I'd like to give it a blue color. And since we're primarily working on this for now, I'll favorite this connection. Make sure, again, once more, that your password field is actually filled in. It should be the full string with your actual password and should look like this. It shouldn't have the angle bracket password holder. Now, after doing all of this, click Save and Connect. And on the bottom left, you should get your connecting string. And now that you're connected. Once you're connected, you'll have this online message right here, and you can work on it. On the left, we can see a few databases that have been created by default. This is a fresh Atlas cluster. You'll see admin, config, local, and sample, and flicks. If you loaded sample data, or just admin if you didn't load sample data. We're basically not going to work on any of these. We're going to create our own database and work on that. So creating a database, hover over your cluster, and on the right, click on Create Database. Let's create a database name. Let's name it TaskDB to store tasks. And inside the collection name, we'll store tasks. So if you remembered, at the very top, we have our cluster. Next to our cluster, we have our database. Inside our database, we have collections, and in collections, we have different documents. So click on tasks. So just type out task and click on Create Database. Once you click on Create Database, you'll see your TaskDB created with your collections folder inside it. Click on your task collections. Right now, this collection is empty. It has no document inside it. So let's add a document on our own. So on the top right here, click on Add Data and click on Insert Document. A JSON editor will appear where you can write our own document. So the default ID, let's remove the ID for now. We don't actually need it. Let's start fresh. So for example, we want a title. For the title, we want setup MongoDB Atlas. Well, any value really. Next, we want completed. So let's try Boolean values. Yes, we do store Boolean values. We can set a priority to high, but this would have to be a string. Then we can have tags. I want to use tags to demonstrate that we can use arrays. So inside tags, you can have different tags. So MongoDB, you could have setup, you could have Atlas. Next, you can have an embedded document. So your embedded document would be created at, and inside created at itself, it is an object, and inside it, you can store the date. So I don't really want to type out the entire date right here, so I'll just type in 2025-01-01. Technically, you'd have your time zones behind this as well, but I'll just leave it as is. This is actually how you specify a date type in JSON editor. Compass will store it as a proper BSON date and not a string. So to do that, it actually seems like I need to give in the proper date. So I will give in T000000 dot 3 zeros followed by a Z. So this will store it in a proper time zone format. Now there it is. It is our first document, and let's insert it into our database. So once we insert it in our database, we can see that the created at is actually a date. It's a date itself. In our tags, we have an array with 3 things inside it. We get an ID that is inserted to us by default. We actually never have to manage this ID. We just use it to reference other objects sometimes. We have our title, completed, true, priority high, and everything. Let's add a few more documents. So I'll add another document right here, and using insert documents, I'll add in yet another one right here. So in total, we have 3 documents in our database. Specifically, inside our database, inside our collections, we have 3 documents. Now let's look at the view toggle buttons on the top right. So if you come to the top right here, we have our list, we have our JSON, and we have our table. So you have 3 view modes. List view, this is the default mode, which shows each document as a card like this. We have JSON view, where it stores the raw JSON that we looked at earlier. This is also the type of data that we pass in to actually create a document in MongoDB, aside from this ID. Then we have the table view, which displays documents like a grid, like a spreadsheet. Let's just look at table view for a while now. Notice something interesting here. The column names are automatically derived from the fields in your tables. It looks like an SQL table, but the underlying data is still flexible documents. This view is great for non-technical people who are used to spreadsheets. So you can show them this view and they would pretty much understand it. But as developers, let's switch back to our list view where you'll be mostly working. At the top, we have our filter input bar. So your filter bar right here takes a MongoDB query object, the same syntax that you'll use in your CLI and in your Node.js code. Let's filter for only incomplete tasks from here. So we simply want completed that are false. Click on Find. It will return you with documents that have completed false key and value. It's just one document with write Node.js API. That is only our incomplete task. The filter syntax is exactly the same as what you'll write in mongosh, which is your terminal editor, and in your application code. Learn it once, use it everywhere. It's actually pretty simple. You just pass in an object of the thing that you want to find inside your documents. Now let's clear our filter. Once we clear our filter, everything will appear back again. Next, we can look at the Schema tab. This is one of Compass's most powerful features. Click on Analyze Schema. Compass scans your documents and gives you a breakdown of every single field. What data types are stored, what % of documents have that field, and for string and number fields, a distribution of different values. For your ID fields, you also have your date and your time. Completed, so you have true and false. We can see that 67% is true and 33% is false. You can see created at. We can see our priorities. We can see tags, so different tags that we have. So usually these tags have a minimum value of 2 and a maximum value of 3. Then we have titles. So the 3 different titles that we had were Learn Compass GUI, Set up MongoDB Atlas, and Write Node.js API. And we can also refresh this to get the latest data. This is incredibly useful when you inherit a database and have no idea what's actually in it. You can see the priority has 2 distinct values like high and medium. Completed is a split between true and false. This at a glance tells you the shape of your data and what your data is leaning towards. Go back to the Documents tab. So in your Documents tab, let's apply a filter. Let's apply a filter of priority. So let's look for priority high. And on the right here, click on the Explain Plan tab. So clicking on the Explain Plan tab it tells you how MongoDB executed that query. Right now, it says col scan, which actually means collection scan. That means MongoDB looked at every single document to find matches. For 3 documents, that's fine. For 3 million documents, that's really slow. When we get to the CLI section, I'll show you how to create an index on the priority field. And then you'll see this change from col scan, so checking all of the collections, to IX scan, which is index scan. It's actually dramatically faster when you're dealing with a lot of data. For now, Compass is your visual window into the database. Keep it open while you're developing. You'll constantly use it to verify that your code is doing what you think it is doing. And in the meantime, you can look around, you can snoop around, create some databases, create some data, create some documents, and look through everything that we discussed in this part before moving on to the next one. Click on Database and Network Access. Go to your IP access list, and right now you'll get your current IP address listed here. But if you want to be able to connect to your database from anywhere, you simply want to click on Add IP Address. Access list entry should be 0.0.0.0/0. So what this will do on the top, it'll give you a warning too. This access list entry potentially allows access to all IPv4 addresses. So you can access your database from anywhere. I won't create this because my current IP address serves my purpose. So let's go to our project overview. If you ever finding problems with connecting to your database with timeout issues, it's likely that your IP address is being blocked. So it's a good idea to allow all if you're having those issues. So your cluster was being provisioned and now your cluster is created. It takes about 2 to 3 minutes. It'll appear on your dashboard with your project 0 and with your cluster. My cluster is named Learn MongoDB and it has been created. And we want to connect to this cluster. So click on Connect right here. When you click on Connect, you'll get that dialog box that you got earlier already. And click on I have MongoDB Compass, or click on your Compass. In the connection dialog box, choose Compass first so we can copy our connection string. And click on I have MongoDB Compass installed. We will do this shortly, but you'll see a connection string that looks like this. So you have your database user automatically filled out for you, and the DB password is empty. You're supposed to use the one with the account that you created earlier, and you'll have your cluster and your cluster location. So copy this, replace the password section with the actual password of the user that we just created, and save it in a text file somewhere. This is your Atlas connection string. We're going to use this in Compass and in DataGrip, in Node.js, everywhere. Now, if you'd rather run MongoDB locally, go to mongodb.com, click on Downloads, or click on Products, and look for Compass. Download free for your device and set this up as usual. So MongoDB Compass download GUI, set up your operating system, your packages, click on download, run the installer, and MongoDB Compass will be set up on your device. Next thing that you need is your MongoDB community server. So MongoDB Compass is a way for you to access your database with a GUI, whereas MongoDB community server is the actual database being hosted locally. So you can install this on your device, and once you install it on your device, you can run MongoDB databases locally. Okay, once you've installed your MongoDB and your server, now you should successfully see it if you open up your PowerShell and type MongoDB -- version. You should see your database version with your build's information. And now your local connection string is always MongoDB -- localhost 27017. So every time you're trying to connect to your local cluster, use this connection string, but we will be using the connection string in Atlas for now for everybody's ease. But everywhere you see my Atlas connection, if you want to use your local database, use the connection string that I just showed you on your screen. Now open MongoDB Compass. Right, once you've explored everything, let's start this section. This section is for the CLI, which stands for Command Line Interface. This is where MongoDB developers live for quick operations, migrations, and debugging. Every single thing that Compass does visually right here, you can do here, and then some. If you get comfortable in MongoSH, you're never blocked regardless of what GUI is or isn't available. MongoSH is the MongoDB shell. It's a JavaScript REPL. That means you can write actual JavaScript in here, not just databases commands. So read, evaluate, print, and loop. After you download this, just extract it, and once extracted, you'll get a folder like this. So go into your bin. You can either add this folder to your environment variable so that you can access it from anywhere, but I'll just open up a command prompt right here for ease. So you can add this to your path so that you can use this command from anywhere, but currently I'll just use it from right in here. So let's head on to our MongoDB Compass right here and click on these 3 dots and click on Edit Connection. Actually, I'll click on these 3 dots right here and click on Copy Connection String. Once I've copied that connection string, I will type in mongosh and paste that connection string and click on Enter. It will attempt to connect to my database, and once it's connected, it will give me this prompt that says primary test right here. Now, test is not the database that we want to select, so we should change that. But before that, let me explain what this is. So let me full screen this. The prompt shows you the cluster name at first. So this is your cluster name and which replica set member you're connected to. So we'll talk about replica sets later, but primary means you're on the primary node which handles all the writing. Now, in your prompt that you get right now, we can list all the DBs by simply typing show DBs. We can see that we have a sample mflix, taskdb, admin, and local. The one that we've created was taskdb. Simply just use taskdb. So we're switched our database to taskdb, and you can see the prompt changes from test to task. And if it doesn't exist, MongoDB would create a new database for you the moment you insert your first document. Your prompt changes to taskdb. Now inside our database, what's the next thing that we have? So we're connected to the cluster right here. This is our cluster. Inside it, we looked at the databases, and now we're connected to a database. So the next step is looking at the collections. So show collections. Inside our collections, we'll see tasks. Task is the collections that we created in which we have 3 different documents as we did earlier. Let's create a new document. So db.tasks, so the one that we're creating, the current DB that we're using is switched to db taskdb. So db refers to taskdb. .tasks .insert one. So we want to insert one document, and that document will be, let's type it in right here. Currently, we inserted a document, but we didn't really pass in any value. So it just created a document that is empty. It will show the output, acknowledge true, and inserted ID with the object ID of the document that we just created. This is MongoDB confirming that the insert was acknowledged, meaning the primary node received and stored it. And it shows you this inserted ID. The underscore ID that was auto-generated for this new document is actually this ID that right here that we talked about earlier. If you need this ID for something, you can actually capture it by storing it in a constant and then using that constant. So let's try to insert multiple documents at once. So we used insert one to insert a single empty document, and we can actually view this in our Compass. So go to your tasks and refresh this. So once we refresh it, we can see that an empty ID document has been inserted here without any fields. And we can go ahead and flag that for deletion and click delete. Back in our MongoSH. So db.tasks, we used insert one to insert one document, and we can insert many by using insert many. Encompass this inside your parenthesis, and inside you want your curly braces. We can insert many documents by using db.tasks.insert many. So earlier we used insert one. We can insert many by using this. For this, you have to provide an array of documents that you want to insert. So open your bracket for your function, and I'll open the bracket for an array. So inside the array, the first document that I want to insert, I'll give in a curly brace, and let's type right here. And for the title, I'll give title setup Atlas. And next, I'll give it a completed, and I'll give it a Boolean value false. I'll give it a title priority, and priority will be set to high. Next, I'll give it a created at, so created at, and this is going to be new date. As I mentioned before, we can use this in MongoDB. I'll close this document, and after that, I'll give it a comma, and I will add another document. So this first document was the first item of this array. This array's first item. I'll pass in a second item. So for the second item, I'll give in the title Connect Compass. So Connect Compass. I'll give it a completed, let's say true. Then I'll give it a priority. Priority will be set to high. And I will also give this a created at, and created at is simply again going to be new date. And these are the two items that I want to insert currently. So I'll simply close my braces, close my array, and then finally close my function. So after you closed everything and if you press enter, this will go through. So in Mongo as such, always make sure that you're not closing your braces or closing your parentheses before you actually want to end it, because doing that will lead to it ending quicker. So acknowledged is right now true and inserted IDs is 0 and 1. Now next, let's run it, and after we've run it, we can see that 2 documents have been inserted and we have acknowledged this from MongoDB. Alright, the next thing that we're actually going to do is search in the database. Now you can search using different filters inside the database, and let me show you an example. So our database currently selected is taskdb, so I just need to write db.tasks. So tasks is my collection name, and in my collection, I want to find something. So the thing that I want to find is using this filter, so completed false. So anything having the completed false property or having this key value pair inside that document will appear. So if I press enter, it will give me 2 documents. So it gives me a list of documents, first of all, and it gives me this first document. So this first document does have this completed false, and the second document also has this completed false. The object that you pass right here, so this right here, it's called the query filter, and it's the same syntax everywhere. So let's search using filters again. So I'll write the same command out again, but instead of completed false this time, I will search for priority and anything that has the priority high. And let me give in another object. So I want the title 1 and underscore ID 0. So I'll press enter and I get 4 different objects or 4 different documents, but just the title of those documents. So the second argument right here that we pass to tasks.find or the .find method is called projection. It controls which fields are returned. Title 1 means I want to include this field, so I want the title. 0 means to exclude it. Here we're saying give me only the title field and suppress the underscore ID. Again, what you could do right here was give me, if you wanted everything but the ID, then just give ID 0. So it gives me everything with the priority high, but it doesn't return the ID. Whereas if I didn't pass this out, if I simply just ran it normally, I would get this ID as well. So the second argument that you pass right here is called projection. So in projection, if you basically want only one thing, you'll type it out right here. If you don't want something, just exclude it by giving it the value 0. So CLS to clear screen right here. And the next thing that we get is we're going to look at to find something is called find one. So this is generally when you want to find users. So I can look for find one and title learn Mongo SH. So hopefully this should return, okay, it returns no. So let's look at everything that we have currently. So let's go up and priority high, sure. So we have something called setup Atlas. So I can do find one and write out setup Atlas. So it gives me one object. So every time that you run db.tasks.findOne, it returns the first matching object and it doesn't return a cursor, so it doesn't return this list of other objects. This is good when you know you want only one result. So for example, if you're searching for a user by their email, you don't want multiple users to show up. You just want one user and that is your user. So a better example of this would be, you see all of these documents. So all of these documents have the priority high, and if I just want the first document with the high priority that it finds, so I can do the exact same thing, and instead of find, if I write find one, it will just give me the first one. So if I did a normal find without doing find one, it would give me all of those objects, whereas if I did find one, it would just give me the first one. So set up MongoDB Atlas, it just gives me the first one. Simple as that. So let's play around with some more functions of DB tasks. So we can do db.tasks.find and not pass in any arguments. So after not passing in any arguments, we can do .sort. So .sort will simply sort out all of the results that we get. So we can do something like created at and give it a value of -1. So if you use 1, it gives you everything in ascending order. If you use -1, it gives you everything in descending order. So we want created at in descending order. It means that the one that was created earliest will show up the first. So as you can see, this one was created at 2:13:45, 2:13:45. This one was created at 00:00:00. And if you want to use ascending, so this object will show on the very top if you use ascending. So if I do that, that object is so set up MongoDB Atlas, instead of at the very bottom, it shows up at the very top. Now, if you want to sort by your title, which you usually do, so instead of created at being in ascending order, you can use title. So it will sort the title in ascending order, which means this is in alphabetic. So LMNOPQRS, UVW. And since this is small letters, so the title is in small letters, then it starts with the small letters first. So one thing to keep in mind is that larger letters, so a capital casing and small casing does matter in this case. Now you can mix both of those. So you can mix the db.tasks.find and give it an object. So completed false. This is our search filter. And you can sort. So everything that you get, I want to sort it with created at of -1. So I want to sort everything that you give me with descending order. So it gives me everything, but it sorts it in descending order looking at the created time. You can keep on chaining a bunch of methods behind this. So there's another method called limit. So if I limit it to 1, I will get only 1 instead of getting 2. But the difference between putting a limit of 1 and simply just using find1 is different. So find1 doesn't actually have this .sort function. It's because if you're finding just one element, if you're looking at just one element, it will never sort it. It will just get the first element that it sees. So if you want one element only, but you want to be sorting it, or you want to run other methods on it, you have to use find and limit 1. If you just use find1, you cannot sort it or anything like that. It'll just get the first one in that order. So obviously you can chain all of these elements, you can chain multiple elements. So we'll be looking at this in perfect examples too later on. So the last thing that we'll look at that's really important when you're searching for documents inside a collection is db.tasks, so your task collections, .count documents. So you can probably assume what this does. And of course, in this also you can throw in a filter, but if you don't throw in a filter, you get all of the documents. If you do decide to throw in a filter like anything with completed false, it will also work in that. However, if you try to limit it, so you cannot use .limit in count documents, because if you're already counting documents, you can not really limit it 1 because this would always return 1. So you can chain multiple different methods with different other methods, but you have to make sure that you don't chain things like count documents and limit or find1 and limit. So those are all of the methods that we looked at to actually search for documents. Now you might ask why we need to count documents. Well, sometimes you need to, suppose, show 10 documents in one page, or you want to show 10 users in one page. So you want to know how many documents you have to calculate how many pages you need. For example, if you have 50 documents, then you'll likely have 50 divided by 10, so you'll have 5 pages. So this is needed for backend logic. It's mostly used for backend logic. It's also to basically just count how many users you have, or if you want analytics and such. So for the first part, reading all the documents, the first thing that we looked at was db.tasks. Well, let me clear the screen. So the first thing that we looked at was db.tasks.find, which basically looks at all of the documents that you have and returns everything in that collection. Then we did the same thing. So we did db.tasks.find, but we actually passed in an object like completed false to query it. So this is our field. It's called our query filter, and we pass that in. The third thing that we looked at was, instead of just find, we looked at find1, which returns the first element. The next thing we looked at was find, so db.tasks.find, and at the end we chained in a sort. So we could sort ascending or descending based on different things. So minus would be descending, plus would be ascending, and you can set it to filter out certain fields. Next, we looked at db.tasks.find dot and changed it to sort. So we could sort with a certain object, so completed false, and we looked at dot limit. So in the limit, we could get a certain number of documents that we like. Next, finally, we looked at db.tasks.count documents. So it would count documents in everything that we had. So in our entire collection, the number of documents that we have. So we looked at 1, 2, 3, 4, 5, 6 different methods to basically just read from a database and look at the data that we're handling in the database. Now we'll move on. We'll move on to actually modifying these documents. So you can modify the documents inside the shell editor itself. However, it's not really recommended that you do this, but you can have this knowledge anyway. So the first method that we have is db.tasks.update1. So I'll open my bracket right here and I will press enter, 1, 2, 3, and I will get the title. So for example, the title would be learn mongosh. I'm not sure a document like this exists, but we'll look at that then. And next I will look for a $set, and I'm going to $set completed as true. And I will close this out and press enter. Now I did not get this. It said acknowledge true, but inserted ID null. That's because this title did not actually match anything. So I can do db.tasks.find to look at all the documents I have. Okay, so I have a setup Atlas. So instead of running MongoDB sh, I will do setup Atlas. So right here, I'll just pass in setup Atlas. Now it's set, and I'll set the completed value to false. And let's press enter. So it said acknowledge true, it matched 1, and it modified 1. Look at what upsorted means, but it did that. So now if we find our db.tasks and look at our Atlas, so Atlas right now is completed. Now it's set to false. We can change it back to true by simply changing this value to true and pressing enter. And let's look at it again. The setup Atlas completed value has been changed to 2. So let's look at this argument, or let's look at this instruction. So the first field that we pass in inside our update 1. So notice that it says update 1. So we're updating only one document inside that collection. The first argument that we pass in is to find which document to update. And you can find by title, you can find by priority, you can find by tags, created at, ID, object ID, anything. For example, if you passed in priority, so anything with priority high, you want to set completed to true. It would find the first item with the title, or actually the priority, which is high. So it would probably just change setup MongoDB Atlas. It wouldn't touch anything else because we're updating just one. Next, we have this argument. So inside this argument, we're basically saying set, so $set. And inside $set, we're looking at the new value that you want to change. So completed set to true. It does not replace rest of the document. So when you use $set, the rest of the document stays exactly the same. Only the value that you explicitly mentioned gets changed. It just changes the fields that you specify. And once you run it, you'll get this object. So acknowledged is true, and matched count is 1, modified count is 1. So it found one document and modified that document. So if you actually run this command again, so completed is true for setup Atlas, and if you ran it again, it would say matched count is 1, but modified count is 0, because it is already set to 2, so it cannot really modify it to be true or. Next, as we saw update 1, there is another function for update many. So it's literally just called update many. Now, instead of just updating one, it will update all of the documents. So I can set priority to not setup Atlas, but in this case, priority to high. And let's run this. So it matched 4 and it modified 1. So what does that mean? It found 4 different documents with priority high. 3 of those documents already had completed true, so it did not change anything. But one had completed false, so it changed that one which had completed false to become completed true. Now, what if you want to add a new field? So everything with a high priority, I want to add a new field called urgent and set it to true. So I can just simply set it like this, and it will find 4 of those documents and modify 4 of those documents to add this property. Now, if we db.tasks.find and we look at everything with high, we can see that all of them have this urgent true. However, ones with the priority medium weren't selected by that query, so they don't get that urgent true. So you can use tasks.updateMany to update a lot of the documents to add new fields or change existing ones. You can use db.tasks.update1 to update the first document that you find or add new items to that first document. So the next thing that we'll be looking at, you won't be using this much, but I will show you how to use it. So we have update1 as we normally do. And inside update1, let's say the title is setup Atlas. Next, we can do $push instead of $set, and we can give tags, for example, done. And we can end this and press enter. So it says acknowledge true, inserted null, matched count 1, modified count 1. What happens if we db.tasks.find and find this document? So to find this document, we simply have to give in an object with our filter in it. So set up Atlas, I want to find this document. And if you look at it, inside the tags, so it created a new array, and inside this array, it added the value done. So $push actually just modifies arrays. Now here's a few So our tags key is completely removed from this document or this object. You can update one CLS. Instead of unset, you can do INC. So INC would simply increment a numerical value. And next, you can do pull. So pull will just give you a specific value from an array. So you can try those out by yourself. I'll put them on screen right now. The last thing. So db.tasks.find. What if you want to completely remove a document? So for example, you want to remove this document with the title Connect Compass. So you'd simply just do db.tasks.delete1. And inside delete1, you'd pass in title, and title will be Connect Compass, for example. Once you do this, it will acknowledge true, deleted count 1 though. It's because this compass has 3 S's for some reason. So instead of, okay, so it acknowledged it and deleted that document. So now if we db.tasks.find, try to find the document with the title of Connect Compass with 3 S's, it returns us with nothing because it doesn't find the document because we deleted it. Now, just like we use deleted one, there's another thing called deleted many, and it does exactly what you would expect it to do. Simply, instead of one, you write many, and all of the documents that match that property of the filter that you sent will get deleted. But be careful with this in production. In production, you really cannot undo deletes directly from the database. So you always have to verify with your find before running delete many. Because once you do delete many, you cannot reverse it or bring that data back in any way. Next, we talked about column searching and index searching at the beginning of last section. So when we're using column searching, the database searches it relatively slow, and when we use index searching, it searches it relatively fast. Now, how does that work? So let's test it out. db.tasks.create index. So we create an index and we set the priority of the index. For example, we set a priority of 1. So this creates an ascending index on the priority field. Any query that filters by priority will use this index of scanning every document. So you can look at the indexes by doing db.tasks.getIndexes. And I'll explain all of this. So we have first index already made by MongoDB, which is our ID index. Next, we created a new index with priority 1 called just priority 1. You'll always see that at least 1, which is _ID, the default index. Now, you can do db.tasks.find, let's say priority high, and chain along with it explain execution stats to see how it's being executed. Oh, priority high needs to be in quotations. And let's look at this output that we just got. So right here in our execution, in execution stages, so it's not cached. Cached means it's not stored in local memory anywhere. It's every time we search for it, it searches in the database. We're fetching. When we're fetching, we're returning 3 documents, and we're doing all of the stuff that you really don't have to understand. But in our input stage, Earlier, we were using COLL scan, which is column scan. Docs examined equals your total document count. After, now we're using IX scan. So docs examined equals to only the matching documents now. So only 3 documents right here. When we searched for anything with priority high, it just looked for documents and it found 3 documents. It does not look for any other documents that do not have this priority. And because of our index scan, this is possible. At a scale, the difference is actually seconds versus milliseconds. And that seconds versus milliseconds. So scrolling down here, we can see that the key pattern used was with priority 1, and then the indexing name that we used was priority 1. So again, to recap, anything that the index does versus what the column scan does is column scan scans through all of the documents to find the documents which relate to that field, whereas index scan simply just directly finds which documents have these high and directly returns us with them. So that is the complete CLI toolkit, every operation you'll need with creating, reading, updating, and deleting, and index management in MongoSH. Now let's take everything we've learned and write actual Node.js code that can talk to this database. So right before that, let me connect to our MongoDB cluster. After we're connected right here, I'll go to my task DB and I'll open up my task collection. And inside my collection, I will just, for example, filter priority high. I'll press enter and I'll click on explain right here. So now we're using IX scan. So IX scan's index name is priority 1, and then the only documents that it returned were 3 documents. So the execution time, since we have very little documents in this collection, it shows 0 milliseconds, but in real production code, where you have thousands, potentially millions of documents, it's significantly faster. Okay, I've opened up WebStorm right here. You can continue this part in VS Code as well, but I'll simply create a new project, and inside WebStorm projects, I'll just name this MongoDB tutorial. And we're going to use JavaScript. I don't want to create a Git repository, and I'll click on empty project. Seems like I need to insert that name again, MongoDB tutorial, and I'll click on create. So once I do that, my project is going to get created in VS Code. All you can do is simply open up a fresh new folder. So I'll exclude my folders from Windows Defender, and we're here. So in VS Code, if you're following along, simply just open up your terminal, and we'll set up a few things in the terminal before we start. So this is where everything comes together from a developer perspective. We're going to connect MongoDB from Node.js using official MongoDB driver. This is the raw driver, not Mongoose, which means you'll see the exact same query syntax as MongoSH, which you know now. Later, once you understand this, Mongoose just makes it easier and adds schema validation on top. So I've opened my terminal up. After opening my terminal, I want to initialize my npm package. So I want to create a Node.js application inside this folder. So I'll initiate my npm package. Okay, my npm package has been installed. So I'll clear up this terminal right here. What you should get in the result is a package.json. And if you open up your folder right here, you should see that you have a package.json file with really nothing in it right now. Inside it, I want to install 2 packages. So npm install MongoDB, the raw official MongoDB driver, and .env. So I'll install these 2 dependencies. And after installing these dependencies, I will clear it out. So the reason why we need MongoDB is to obviously connect and do everything that we did in MongoSH. The reason why we need our .env is typically you don't want to keep your MongoDB connection strings inside your files itself because you might be pushing to GitHub or something. So it's ideal that you want it inside a .env file. So the first thing that I'm going to do is I'm going to my project root and I'm going to create a new file. So the new file is going to be an env file. So I'll just create a file and name it .env. And inside .env, I will create a variable mongo URI equals to. So if you don't have it right now, go to your MongoDB Compass, click on this right here, click on copy connection string, and paste your connection string right here. So You don't need to put in quotation marks or anything, just paste it right here and save your file. So after doing this, notice that at the end, you actually type in taskdb because it makes sure that your application is, or your connection string actually directly leads to this database right here. It just tells the database driver which database to use by default. Obviously, you can specify to use other databases inside the string, but for this, we'll just use this. The next thing that we want to add is we want to create a new file and name it .getignore. Now, you can have this done automatically for you inside WebStorm, but since some of you might be using VS Code, I'll do this all manually, but this is basically for version controlling. And inside this, we want to add node modules, and we want to add env. So basically what getignore does is if you want to make your code public or you want to share your code, you don't want to share these two files, or this folder and this file. You want to share everything else except that. It's actually very important. If you miss this and accidentally commit your .env file to the public, anyone might use that connection string to gain access to your database. So in your package.json right here, the next thing that we're going to do is inside your type, instead of using common.js, we're going to use module. So instead of using the old syntax, we're going to be using the modern ES module syntax. And if you're familiar with backends a little bit, you'll know what this means. But if you're completely new to this, just follow along for now. So in our project root, we're going to create a new JavaScript file, and this JavaScript file is going to be named db.js. You can name it whatever you'd like. I named it db.js, and let me zoom in right here. The first thing that you need to do, you need to actually import what we just installed. So you need to import your Mongo client from MongoDB. So this lets us connect to our client. Add some spaces here. Next thing that you need to do is obviously import .env from .env. Simple as that. And the first thing that you need to do is .env.config. So it initializes your .env file so you can load anything from it now. And we're going to create two variables. So we're going to create client and we're going to create a database variable. Next, we're going to create a function that connects our code to our database. So to do that, we're going to export first of all. So export is the ES module syntax. It basically means that anyone, so any other file, should be able to access this function if they are living somewhere else inside this project. So we'll do that too, so we'll look at that. And async. So I'm assuming that you're pretty familiar with asynchronous coding, but async basically means that this function is going to make a bunch of requests that might take time. We're going to create a function, and this function is going to be named connectDB. And as you can see, it says that it returns a promise because async is internally resolved to a promise. So if db, return db. So this is something that we call a singleton practice. So singleton is a very common term used across many programming languages. So this is what we call a singleton. Basically, if we're already connected to a database, so if db as in right now, we shouldn't be connected to any database because we haven't. But for example, this script is running for the second time. Well, the first time we'll already connect to our database, and the second time this will actually have a value. Right now it doesn't have a value. So this having a value means that a database has already been connected. And if we've connected to a database already, just return that database. We don't want to create double connections. It's a lot messier. So that is simply what we do. If not, then we go right here. So we create our client. Actually, our client has already been created up here, but our client is going to be a new Mongo client. process.env.mongo_URI. And it might show you an error here because it cannot actually access that variable inside this file itself. But trust me, once you do .and.config, it will actually pull the Mongo URI variable into this file itself. So that's the first thing that we do. We create a new client. So the client is a new Mongo client, and the Mongo client is, we pass in the URI. Right after that, we do await. So await, we wait for something to happen. We're going to call client.connect. So now we initialize a connection. Our client already has that URL where to connect to, and it's going to connect to our database. After connect to our database, we're going to update our DB variable. So our DB variable is going to be client.db. So this is where our database variable has been created. Currently, it had no value in it, but we created a client We call the connect to connect to our database, and then we pulled in the DB from the client. So by default, we're connecting to our task DB because in the file right here, in our env file right here, we specified task DB towards the end. So it's going to give in our task DB by default. So after this is done, we simply want to console.log connected to MongoDB. Let's just say that. And actually, let's take it one step further. So use template literals. I'm sure you're familiar with template literals. And inside the template literal, I'll put in a variable. And this variable is going to be db.database name. So it'll simply return us with the database name of that DB, so of this DB. Press enter a few times after this. So this is our entire function. This is the entire function to connect to a database. So the first thing that we check is if you're already connected, you don't want to do anything, you want to return out of the function. Next thing is we create a client with the URI that we passed in. Whatever database we're connected to by default, we're going to connect to that, and we're going to store that in a variable db. And we're going to print out db.database name. So we're going to print out the name of the database that we're connected to. Next, we'll have another function right here, so export async function, and this is going to be to close the database connection, because after opening a database connection and doing everything, you want to close the database connection in the end. So if our client exists, so our client must exist, then await client.close. So earlier we did client.connect. Now we're doing client.close. We cannot directly do client.close because imagine we haven't connected at all. It would throw an error. We have to check if our client is connected first. Next, we're simply just console logging disconnected from the database and db.database name. And that is our entire function. So I'll zoom out a little bit. And now you can copy this or you can commit this to your memory. So the next thing that we're going to do is we're finally going to do some CRUD operations, which is creating, reading, updating, and deleting data in the database. So in our project root, I'm going to create another file, and it's going to be a JavaScript file. It's going to be named tasks.js. Inside tasks.js, we'll be doing all of our logic. So first of all, we're going to be importing object ID from MongoDB, because to modify any documents, you need its object ID as we did before. Well, before we filtered by name and such, but now we need our object ID. The next thing we're going to do is import our connect DB from db.js. So as you can see, the only reason that we can import this is because we exported it. Since we exported this function right here, and right here we imported it, so it's as if this function was inside this file itself. After that, we're going to create a function of our own right here. So we're going to create a function, and the function is going to be named run. This function is going to do a few things. The first thing that it's going to do is it's going to create a constant db equals to await connect db. So the first thing that it does is calls this connect db function. So connect db, we imported it. Just because we imported it doesn't mean that it gets called right off the bat. So we imported it and then called it. After calling it, we stored the output inside our db variable. If you look right here, we have a db variable right here, which is client.db, which gets stored right here. Next, we want to const tasks. So task is actually our db.collection task, because we've already made this in our MongoDB Compass. As you can see, task is a collection that exists inside our task DB database. After we've selected task DB, now we're going to create. So let's create something. Create. So first of all, we're just going to console.log to show that we've connected. So right here, all we're doing is, let me create an escape sequence. So /n will take us to the next line. And right here, we're going to be inserting. Okay, so the first thing that we're going to do is create an entry. So insert. Basically what we did in the CLI, but write the code out for it. So constant insert result. So earlier we got our result right in the command line. So as soon as we sent the query, we got an output with the acknowledged and everything. But in code, you do not actually get it in the console itself. You get it, you store it into a variable. So we have insert result variable. Inside it, we're always going to use await, because every time that you're doing something with the database, there are chances that you won't get results immediately. So we wait until we get those results. We await, and let's start with tasks.insert1. So we're going to insert one value. What are we going to insert? Well, right here, we're going to insert a document. So inside our document, we want to give it a title. So title, for example, learn Node.js driver. Then next, I want to give it a completed. So completed true. We want to give it a priority. So let's just give it a priority of high. Let's give it some tags. So tags, okay, so Node.js, and let's give it MongoDB. Next, we can give it a created at, so new date. Basically everything that we've already done. Once this code hits this piece of line, it will await task.insert1, so it will execute this function. After executing this function, it will return the result into this variable, and we can access the different values inside that object. So right after that happens, we're simply going to console.log, and we're going to log that it has been inserted. So inserted, and we want the ID, right? So the ID is stored where? It's stored inside the insert result. Insert result dot insert ID is where it will be stored. And we're going to create a new constant, so new task ID. New task ID will also be of that value. So now we have the ID of that task. So anytime that we want to look at this task has a hidden, as we saw, a hidden .id right here, but this value is automatically added by MongoDB, and that .id is now going to be stored in our new task ID. Next, after we've created, we're going to read. So you can pretty much guess what we're going to do in this .log, and instead of insert, this time we're going to be reading. And to read, well, we need a variable find, and we're going to pass in a filter. So our filter will have completed false. So anything with completed false is going to be searched for. And let's set a limit just for fun to do, and let's convert it to an array again. Now we can console.log incomplete task count to incomplete tasks.length. Next, I want to find just one specific task. So to find one specific task, I can do const one task. So await task dot find one, and let's say task ID. So our task ID must be, actually not task ID, the ID that MongoDB gives us is underscore ID. Underscore ID should be whatever we created right here. So this is what we created. We inserted this one document, and we want this document back. Where is it stored? It's stored in new task ID. So task ID is going to be new task ID. So this should look through the entire collection and find the one with the ID that we inserted right here. After that happens, we simply want to console.log it. So instead of one task count, we're going to actually write inserted task was just one task. So return the entire task itself. Actually, I just want the title. The title should suffice. And right there. After that, let's look at update. So let's look at the update methods. And at the very beginning, I want to actually pass in a string saying basically what we did right here with template literals, but instead of read, we're going to update. So to update, we already learned this const update result equals to await tasks.update1. And we're going to send in what we need to update. So the first argument is going to be the ID. So underscore ID. Let's search one task, new task ID that we created right on top here. And inside it, for example, I want to set this completed status to false. So first of all, I need to find that document by passing in the ID. The next thing that I want to do is I want to set completed to false. And that is how I can change it. Now I can console.log and I can search for modified count. So what are the things that we got earlier? We got modified count, we got inserted counts, we got documents found count. So it was actually stored in updated result.modified count. Finally, we're going to be looking at one of the simplest ones. So it's actually delete. And inside it, let me console.log. Instead of read, I'm going to console.log delete. And let's delete going to call in close DB. And right at the bottom right here, we're going to await close DB to close the connection to our database. So node, save this, node tasks.js. And when we run this, we actually get connection refused. So this might happen sometimes when you're using SRV strings. So it's a simple fix. So in your .env file right here, we're using a MongoDB plus SRV string. So to simply fix this, head on to your browser and open up your Atlas again and go to connect. So once you click on connect, you want to connect to your drivers and you want to connect this string. So if you see SRV connection strings automatically include all the seedless hosts, which can change servers. So we actually don't need all of this. Simply just remove your SRV connection string, uncheck that, and copy the string. Come back to your WebStorm or your Visual Studio Code and press enter a couple of times and paste that SRV string. Now, one thing that you'll notice is that the password has actually been replaced with DB password again. So copy your actual password and paste in the password right there. Remove your original string and copy this SRV string and put it in your Mongo URI. Hopefully that was not too confusing. We just replaced our normal SRV string with just a MongoDB string. Now, after saving this, we can run this file. So we should actually get connected to MongoDB. So far, so good. We've actually reached this line of code where we've actually connected to our MongoDB and our database name is test. So our database name is test, but in our collection, we're trying to connect to tasks. Well, our task collection doesn't really exist because we're connected to our test database. Since earlier at the very end, we specified a database name, we connected to taskdb by default. But right here, when we're connecting to the DB, we can simply just pass in the DB that we want to connect right here. So taskdb, I think. Or let's check that. So it's actually called taskdb, all right. And save this. So after we've saved that, let's run it again. We're still getting cannot read the properties of undefined. So let's look at what that problem is. In our task right here, we're calling db.collection. So DB seems to be undefined. We're calling await connectDB. We're expecting connectDB to return us with something. So the thing that it's supposed to return is our database. Let's look at our connectDB function. Well, if we created a new DB already, we're returning it. We're creating a new client. We're waiting to connect to that client, and we're creating a database. So we're pulling the database once we've connected. But we're actually never returning that database. So we return a DB if we're already connected, but we're actually not returning it for the first time that we connect. So simply just return DB from this function. After we do that, whenever we call this function, DB is being returned. So the good thing about WebStorm is it'll actually show you all of your data types. So earlier, this data type was undefined, and now it realizes that it's a database. It also realizes that task is a collection with a list of documents inside it, and now everything should be in order. Let's run this command one last time, and we get cannot read properties of null title. Well, let's look at what that problem is. Right here, we're getting a few yellow lines. It says unresolved variable name insert ID. That's because we don't actually get insert ID. Let's look at what this error line is on. So this error line is right here, one task.title. It cannot find the .title, so we need to check the object first. Let's look at this object. One task equals to await tasks.find1 ID with new task ID. Where is this new task ID? It is insert result.insert ID. Well, this should be inserted ID. So now we see that it is a type of document. When we run this one final time, we can see that all of our code has executed beautifully. First thing that we do, well, the first thing that we do is connect to our MongoDB and that database. So right here, we're connecting to MongoDB by creating a new client, connecting with that client, connecting to the DB name taskDB. After we've connected, we return the DB. The DB object is stored inside our constant DB in our tasks file. And we pull out the task collection by simply just DB collection and selecting that collection. The first thing that we do is create. So once we create, we're logging out the ID of the object that was created. So we got this object. Next, we're reading. So we're reading all of the tasks. So all of the task count was 7. Let's see, incomplete task completed false. So none of the tasks are incomplete. Next thing is we're inserting a new task. So the task that we inserted on the top right here was learn Node.js driver. And we searched for that task by just passing its ID. And we got one task. So we're just printing out the title, which was learn Node.js driver. So the title was just learn Node.js driver. Next, after our read, we have our update. So in our update, we simply just took the task ID and we set completed to false. So it shows that we modified one document because we returned update result.modify count. Last thing was delete. So const deleted result. And we simply just deleted that new task that we created. And deleted result.deleted count was 1. We deleted one result. So let me show you a final example of how it would look like if you were working with Express. Just a preview. So in your Express route handler, you'd do something like this. So you'd have your router.get at a certain routes. You'd create an async function where you connect to the database inside that routes. You get your tasks, so db.collection tasks, and you .find the ones which are completed false with a limit of 1, and you convert those to an array, and you simply just res.json, so you send that back as a JSON to your frontend, or just return it from your API. This pattern is always the same. Get this DB instance. So once we get this DB instance, we can do whatever we want with it. We can select collections, we can get the collection values, you can delete the stuff, you can create new stuff, you can run your operations, return the result. It's clean and pretty straightforward. Okay, so in this section, we'll be exploring primarily IDEs. And if you want to continue using VS Code and you're not interested in exploring actual integrated development environments for your programming, then you can skip this section and move on to the final section where we create a project. But if you're interested in taking your development to the next level and using IDEs and all these integrated features that I have been using throughout this video, then stick ahead. The first thing that you need to get is JetBrains Toolbox. Well, it's not a necessity, but it's a perfect way to manage all of your IDEs. And the two IDEs that you need to install are WebStorm and DataGrip. So WebStorm is where you'll primarily be scripting all of your JavaScript, all of your HTML, and everything that you need to do towards the development side. DataGrip is what you might be using to manage your databases, look at your data and everything. So once you have those two installed, Also keep in mind that JetBrains is completely free for non-commercial use. So if you're using it professionally, then you need to pay for it. If you're using it as a student, you don't really need to pay for it. So I have DataGrip open right here. The UI might be confusing if you're using an IDE for the first time, but trust me, it gets easier. On the top left, I can create a new data source, actually connect to a new data source, so you can connect to a lot of databases and do a lot of features right here. But I'll be using WebStorm itself. You can just follow along if you're using DataGrip as well. So I'll exit out of my DataGrip, and in your WebStorm, you have this database button towards your right, and this is the exact same UI that you get in DataGrip. So how do we use it in our project right here? The first thing that you need to do is connect to your MongoDB. So click on data source and click on MongoDB. And right here, if you're connecting to your local host, leave it as is and you can connect. But I want to connect to my Atlas string. So you might come on to your cluster and click on connect right here, select your driver and copy this SRV string. Make sure that you replace this DB password. Or if you just want to connect directly, if you've already connected to your Compass, then you can click on these three dots and click on copy connection string and come right here and paste it. So once you paste it right here, all of your fields will automatically be filled out. You might not have a driver selected, but don't worry about it. Click on test connection. Now this will test the connection to your database to make sure that it's working and you have access and you have all the data required. So it should say succeeded. If it doesn't say succeeded, it might say authorization failure or connection refused. So if you get an authorization failure, then you probably put in your username and password wrong. So you might need to change that, make sure that your URL is right. And if you're getting any other error, make sure that this URL is right, and that's pretty much it. So for the name, I'll just write learn MongoDB, and I can add a color. You might want to color coordinate some of your code. So I'll add a color orange. And after you've done all of this, you can save this as a template, but this is all I'll do. And I can add a comment, so you can add a description. I am using this database to learn MongoDB. And then click on apply and click on OK. So the first time you do this, none of this will happen. You might get a prompt right here if you don't have a driver installed that says you need to install a driver. So simply click on install driver and it'll install the driver for you, and this is exactly what you'll see. So you need to click on your database and right click on it and click on refresh right on top here if you haven't connected. So it should successfully connect. If it connects, it'll show a green leaf right here. If it doesn't connect, it'll throw an error. Now, if you expand this, you expect to see some of your data, like how we did right here. When we expand it, we see all of our databases. But we don't see anything here. That's because we haven't selected any databases. So 0 of 4, click on this, and now you can select your databases. So I can either select all of my databases, or I can just select the default database, which I set up in the properties right here. So right click on it, and click on properties. And you can set a default database right here. So you can set up TaskDB. I believe it is called TaskDB. Right here, you can click on apply and OK. So by default, it will show you TaskDB. You can either do that, or you can not select a default database. That's also perfectly fine. The way you select other databases is simply just click right here and select the database. So inside TaskDB, we have our collections. We have just one, which is tasks. Inside our task collection, we have fields and indexes. This is the index that we created. This is the index that is built into MongoDB. And in fields, we have ID, completed, created at, priority tags, title, urgent. So you can see how you can look at your data from inside here. Now, this is not it. If you double click your task, you will get a data format. So all of this is orange. So it'll query your database to show all of the data that you have. So it'll neatly arrange it into rows and columns. So this is your object ID, the completed. You have your titles, you have your priority. And if it's unset, it means that that certain document doesn't have that property at all. So this document that is set up Atlas doesn't have tags. This document, which is Learn Compass UI, doesn't have that urgent field. And you can change your fields right here. So you can double click it, set this true to false, for example. Set this high to low, for example. And you see that it is highlighted. It doesn't get executed right away. You have to click this button on the top here, which says submit. And once you click submit, your services tab should open up. And after your services tab opens up, it'll show you that that database has been committed. And if you go to your tasks, you can see that we basically changed all of that. Now, the next neat thing that you can do is you can right-click, click on New, and open up Query Console. Now, what makes Query Console better than mongosh or raw queries? It's because it gives you more customization, it color codes everything, it auto-completes your queries for you. So let's run a simple query. So db.tasks. So as you can see off the bat, it is filling out my queries, and I can press enter without repercussions right here, and I can create a filter object. So instead of just tasks, I can do .find, and I can create a filter object. Inside my filter object, I can search for completed. So you can see that completed is actually a column. So completed is a column right here. You can see completed is a column in my database, and I can set it to true. So anything with completed true. And I want to .sort. So .sort, and I want to sort by one field, which is created at. So created at, you can see as soon as I type CREA, it fills it out for me. It shows it as a column, created at, and I want to sort it descending, so -1. And no matter how much I press enter, I can keep running queries. So how do you actually run this query? You press this execute button right here, and it will tell you to select a statement to execute. So either you want to execute just the .find part, or you want to execute the .sort part. You can select it right here, or you can simply select it with your mouse and click execute so that it'll execute everything that you selected. And actually live time shows how long the query took. It actually took 3 seconds because the first time it takes longer, and the second time that you run it again, so if you run it again, it took 420 milliseconds, so it takes a lower time. And task.find completed true. So the two tasks which were completed true have been returned to us in a table format. So you can look at it in a table format easily. And if you want to look at the query that actually ran, you can see the query that actually ran. The good thing about this is that it gives you everything in a table format, and you can look at it like how you would in MySQL Workbench. And it is pretty neat. All the operators from mongosh, all the methods, all work in the same syntax, and honestly, I prefer using this much more than using Compass or using mongosh. I only use mongosh when I actually have to use it in production servers, but on your local server or on your local device when developing, using this is much more efficient at looking at data. So let me just spell out the decision quickly so you always know what research tool to reach for. First, number 1. Use Compass when you're exploring data you've never seen before. So for example, when you want the schema analyzer that we talked about, or when you're sharing your screen with a non-technical person, they might get overwhelmed with all that is on your screen right now. You want to use DataGrip or WebStorm when you're actively developing and don't want to context switch out of your IDE. So you want everything to be inside your IDE. You don't want to go to another software to look at your data and then come back to your IDE to change that data. You want it all in one place. The inline editing in your IDE and your console are all great tools for development. And I would recommend you check out the version controlling systems, the debugging systems that come inbuilt with your integrated development environment. Use mongosh CLI interface that we looked at in command prompts when you're writing migration scripts, or when you're SSH'd into a production server, or when you need to run batch operations. Use your Atlas UI when you're actually managing the cluster itself. So if you're monitoring metrics, if you're setting up backups, or if it's the first time you're setting up the database, you have to use your Atlas UI. They're all views into the exact same data that you use, but different ways to do it. Pick whichever one fits the moment. So my recommendation is use your Atlas UI. Use your Atlas UI in the very beginning to set up your cluster, to monitor your collections, and to monitor all of your data. Then directly jump into your WebStorm and connect your database and move on from there. Anytime that you're ready to push it into your production, then you might want to learn some mongosh as well. So get some practice in the console section of your IDE. Everything up to this point has been individual concepts and tools. Now we're going to bring it all together and build something real. We're going to build a REST API with 5 endpoints that creates, reads, updates, and deletes tasks stored in MongoDB. This is the core pattern of almost every backend you'll build. Master this and you can build basically anything. Before we start, I want to keep Compass open alongside with WebStorm. So let's arrange the windows. But right before that, I want to create a new WebStorm project. So under my projects, I'll come down to new project and I'll create an empty project. Sure. And an empty project, I'll just name it REST API. I'll click on create and WebStorm will create my project right here. After that's done, we're going to install 3 packages. So first is Express, since we're making an API. Second is MongoDB, then we have .env. So right here, let's change everything that we did previously. So expand this. The first thing that we're going to create is a file for .env. Inside .env, we want our connection string. And I'll copy my connection string from MongoDB tutorial right here and paste it. Once we're done with our connection string, let's create a git ignore file. So .git ignore, and inside it, node modules and .env. Once we're done with that, let's go into our package.json, change the type from common.js to modules. And let's create 2 files. So JavaScript file db, and this time JavaScript file called server. So JavaScript file, and let's name it server. We're also going to create a new folder, so a directory, and we're going to name it routes. And inside routes, we're going to create a JavaScript file, tasks. So this is my folder structure. It should look exactly the same to you even if you're on VS Code, aside from this .idea folder. The first thing that we do is enter our db.js. Inside db.js, again, we're just doing everything that we already did. So the first thing that we import is our Mongo client from MongoDB. Next thing that we do is import .env from .env. We initialize our .env config. We create a database variable by letDB, and we export an async function. This time I'll just export connectDB. And inside connectDB, if we already have a connection, then simply return that connection itself. If we don't have a connection, our client equals to new Mongo client process.env.mongodb URI. Let's define our client too up here, let client. And in the very next line, we're going to await client.connect. And in the very next line, db equals to client, not sp, db equals to client.db. And we're going to pull in our database name, which is taskdb. Actually, let's create a new database, so REST API. If this database doesn't exist, it'll just be created. So await db.connect, we will not be doing that. We'll just simply return that database. So if you look in our Compass right now, we actually don't have a database named REST API, but that database will automatically be created for us once we connect to our cluster. And this is clean and simple. This is all we need to do. I hope this is pretty understandable, and I will leave it on the screen for a few seconds for you to copy. Next, we move on to server.js. So in our server, we're creating a classic REST API using Express.js. So you might need to have a little bit of foundational knowledge on Express and JavaScript. So the first thing we're going to do is import Express. Next, we're going to import .env. And next, we're going to import task routes. So actually, let's do this at the end once we've already created the routes. So we're going to .env config again. So .env config. And right next to that, we're going to initialize our Express application into our variable app. So we can use different routes. So app.use. We're going to use a route / tasks, which will be defined in our task routes. So right now we need to import our task routes. So we're going to import our task routes from ./routes/tasks. So we'll have a bunch of routes in here that we're going to use right here. The next thing is on our /route. So let's say get /. So our default /route, this is going to be an asynchronous request. I'm rushing through this a little bit because I'm assuming that you have prior Express.js knowledge. If you don't, you need to check out our video on Express.js before continuing on with this part. So we're going to res.json, so basically send a JSON as response. And inside the JSON, I will send a message not hello world, but I will send a message saying API server running. And below that, we actually need to start this API on a port. So const port equals to process.env.port. If it's not available, we'll use 3001. So that means inside our env file, we need to add a variable called port, and we'll use 3001. Back to our server.js. We're going to app.listen on that port. So we're going to start our application on that port, and we're going to console.log task API running on. So task API running on http://localhost:\the port. Pretty straightforward for our basic server.js template. So we're importing express.env and task routes. We're initializing .m.config so that we can use these variables. Next, we're initializing our application for Express. Next, we're going to use a router that we set up in our task.js. Next, we're getting a slash request. That means if you just route to the domain, so the main page, it's going to show message API server running. And we're starting the application on port 3001. And we're logging out this to our console. Next, task.js. So this is the core of our API where all of our logic will stay. So we're going to import, first of all, router from not routes, from Express. We're going to import router. So router lets us use different files to route. Next, we're going to import object ID from MongoDB. Next, we're going to import connect DB from db.js because we actually need to connect to our database. So we're going to initialize a router of Express right here by simply just calling router. So this is what we'll use to route all of our routes. This is what we'll use to route all of our slash routes. First of all, we want a get route. So I just wanted to return all of the tasks with newest first. So this is where you'll be familiar now. So router.get, which is our pretty standard method at the very beginning, and we're starting with async. Inside here, we always have a try-catch block when we're dealing with data from databases, because it's not guaranteed that every time you do a database query that you get a proper response. If you get a malformed response, then it will simply catch that. So inside our try block is what we want to do. Well, first of all, we want to connect to our DB. So const DB equals to await connect DB. So make sure that we're returning that database right here. Yes, we are. So this will return us with the database, which is actually REST API, which is going to be created. Next, tasks is a document that we want to create, actually a collection that we want to create. So it doesn't actually exist right now, but once we hit this line of code, it will get created inside that database. After we create tasks, I want to .find everything. So this returns everything once I .find. After I .find, I want to sort. Since I want newest first, I will sort by created at. Created at -1 will give me descending order, so the newest first. Then I'll simply convert everything to an array and store it in the task variable. And in my response, I will simply just send that tasks as a JSON. If anything goes wrong, res.status 500, and instead of .send, I will use .json, and I will say error, and I'll pass in ERR. And since this is a very long object, I'll just pass in the message. And that is one of our routes done. I'll zoom out a little bit so you can copy this. So I'll explain it from the top. We have a get route. So whenever we hit the slash route, this is mounted on top of slash tasks. So if we hit the API URL, which is this, slash tasks and slash, we will hit this block. So the first thing that it tries to do, it tries to connect to our database. After connecting to our database, it tries to create a collection. And inside that collection itself, it will find all of the data. It will sort the data, and it will convert it to an array and store it in tasks. Then we're simply just sending that task back from the API. If at return a single task by ID. So we want to search a task by ID. We already did this before, so we know how to do this, but let's implement it in Express. So router.get, so we want to get /ID. So we want to use parameters for this. So $:ID will be replaced by anything that we pass. So it's likely going to be a MongoDB underscore ID value that we saw before. So inside here, the first thing that we need to do is create our try catch block, so try catch. And inside our try block, the first thing that we do is we connect to our database. After connecting to our database, we object ID request.params.id. So request.params.id is the parameters that we send in with the request. The ID is going to be the value that we send right here. It's going to take that and it's going to search the underscore ID field that all of the documents have, and it's going to see if it matches that. And any document that matches this field with this ID will be returned and it will get stored in our task. So there are chances that it might not get found, right? So in the event, if we don't have a task, simply just return res.status 404 no task found. Else, this means that we do have a task, we just send the task in the response. And again, in the catch error block, we can simply just copy the error message from top over here and paste it right here. That is our get a specific task done. Next, we have our post route, so post/task. We basically want to create a new task. To create a new task, basically router.post, and we create our async function. Inside it, again, we have our try catch block, so try catch. Inside our catch, I'll just simply copy paste this. So I'll actually copy this for easier use in the future. In our try, we connect to our database. I'll copy this. And next, we get title and we get priority equals to medium from our request.body. After we get all of this, if we do not get a title or we do not have a priority from our request.body, simply just send a 400 error saying missing required field, which is we want our title. Without a title, we cannot really search our database. Next, we're going to create a variable results where we're going to be searching for that title in our database. So await db.collection tasks, so our task db collection dot insert one. So we're going to insert and we're going to give it an array. So the first thing that we need to pass is the title. Next, priority. Completed by default will be false, and created at will be new date. So we're creating a new task. Well, basically you just need to pass in the title, and priority by default is going to be medium unless you specify a higher priority. At the very end, we're going to send a status, so res.status of 201, which basically means created, and in our JSON, we can simply just send inserted ID is result.inserted ID. So just to send the object ID that was created when we created this document. And our catch error block catches that error. So again, I'll give you some time to copy this. The first thing that we're doing is we're creating a try catch block. We're connecting to our database. We're getting the title and priority from our request.body. So from our request body, we're getting those two things. If either of those two things don't exist, then we send an error right away saying that we need a title to create a document. If both of those things exist, then we db.collection tasks. Inside tasks, we insert one. We insert our title that we got. We insert our priority, which is medium by default. By default, we insert completed false, and we insert our created at. We store the result that we get inside the variable result. So it will have a property inserted ID, which will show the ID of the object that is inserted. And that is it for that. Next, we'll have a patch method. Patch method. We basically want this to update fields on an existing task. So might want to change its name, might want to change its completed status. So router.catch, and we simply just need to give in our ID. And in here, again, the first thing that we need is our try catch block. So I just copy pasted it from the top. Try catch error, we simply send the error message, and inside our try, we connect to our database first. After connecting to our database, const result equals to await db.collection.task. And we're going to update 1. So since every time we just provided with one ID, we want to update 1 every time. And inside it, well, the first thing that we need is what object we want to edit. So we need to find it by using ID. ID is new object ID, request.params.id. So the ID that we pass in, we'll be filtering our results using that. And next is what we actually want to change. So $set request.body. So whatever is in the request.body, whatever body we send, we $set it by that. So if they send just the name, then the title will be changed. If they send just the priority, then the priority will be changed. If they just send the completed will be changed. After this, if result.matchedCount equals to triple equals to 0. So this means that if we didn't find any result, so we tried to search for something, but we really didn't find that ID. That means that this ID doesn't exist. We'll simply just res.status 400, and instead of saying missing required field, we'll say that ID not found because it doesn't exist. A user might pass in a random ID and try to change a value, so they cannot do that. Right after that, it means that everything has successfully completed. Since we haven't returned res.json, we're going to send a JSON, and we're going to send modified count and result.modified count. So we're basically going to send the count of how many documents were modified by this action. So result.modified count, if it's 1, it means that the data has successfully been modified. If it's 0, then it means the data is not modified. Lastly, we'll look at our delete route. So delete is basically if you want to delete a task. First of all, we need our router.delete, and we need our ID. So in here, again, we have our try catch statements as we do always. And inside this, our const result, and at the end, chain a .delete one. Inside the .delete one, we're going to get that ID. So we're going to filter by that ID like we did above. After filtering with that ID, we simply don't need to pass in options. So after we filter with that ID, it's going to delete any object that matches it. If in the case that it doesn't find that ID, so if result.deletedCount equals to 0, that means that that ID doesn't exist and that item hasn't been deleted. If it did exist, then we just send in the JSON saying deleted count is the deleted count. And again, if any error happens, we give the 500 error code. If the deleted count is 0, it means that nothing was deleted. If it is 1, it means that something was deleted. At the very end, we're going to export default router, and we're going to save this file. So in our server.js, this router, which is task routes, is being mounted at /tasks. So on our API, HTTP localhost port /tasks/deletes /tasks/ whatever we pass in right here with whatever request we pass in right here will reach to these endpoints. So I'll give you a brief time to go through all the endpoints and routes again. This is our get route, which returns all of our tasks. It returns newest first. This is our get task, which returns a single task because we're filtering by the ID. Then we have post task, which is creating a new task. Basically .insert one to create a new task inside that database or inside that collection. Next, we have a patch method where we're updating one task. So we're updating it with whatever the user sent to the ID of the user, of the object. And finally, we have delete task where we're taking that ID and we're deleting the object associated with that ID. Right, so we're done with all of this. Now we can successfully start up our server. So hit node server.js, and we're getting an error. Module not found. In our server.js, we need to actually add .js right here for it to be able to find that module. And if we restart our server, we should see that we've injected some variables from our .env. So we've injected our port and Mongo URI, and our task API is successfully running. Now there's two ways to test this. One is Postman API. So you can use Postman to test all of your API routes, or WebStorm itself has an inbuilt API tester, but I'll be showing it in VS Code as well for people who are not using this IDE. So open your VS Code up, and inside your VS Code, so let me come right over here, and to the left, you can click on extensions, and you can get the extension Thunder Client. So after you search for the extension Thunder Client, get it and install it, then go onto your Thunder clients, and you'll likely not have any requests by default, but you can simply click on new request right here, and you can choose the method of the request. You can change the body content right here, and you can change the URL right here, and you'll get your response and request. So if you're using VS Code, you can follow along with this, but since I'm using my IDE, I'll just do it in WebStorm itself. So for those of you who are using WebStorm, click on your main menu on the top, click on Tools, and inside Tools, click on HTTP Client and create request in HTTP Client. Now inside here, we can create different requests. So the first request that we're going to be creating is to create a task. So let's delete all of this, and we're going to be creating a task. So triple hash to create a comment. So the first thing is we want to create. Hello. So the first thing is that we want to create a task. So this is a post request. It's a post request to HTTP localhost 3000/tasks. That's it. So if you're on your VS Code, you would put this in the URL, you would choose the post request. That's it. And content type is going to be application/JSON. So this is selected by default in Thunder Client, so you don't need to do anything about that. Now head on to your body section in the Thunder Client if you're there, and given this JSON. So I want the title to be build a task API, and I want my priority for this task to be high. So let's actually look at how this would look like in code first. So inside our code, inside our task.js, well, let's go from the very beginning. HTTP/localhost 3000. So it hits our API. Then we're hitting /tasks. Once we hit /tasks, we get routed to our task routes. Inside our task routes right here, we get the base path, so slash, because it's on the root, there's no slash something behind this. Then we're sending data in application, so JSON format, and we're sending this data in the post request. So let's head on to our post route. Our post route takes in a title and it takes in a priority. So we passed in a title and we passed in a priority. What does it do with them? Well, if they don't exist, it sends an error. Well, this won't happen. It will await db.collection, and it will create a new document with that title, with that priority, set it to false completed, and set a created date. That's all it will do after connecting to our database. If we get any error, then we will get this error code 500. If it happens successfully, we should get 201 with our object ID returned. Now, inside our MongoDB, you can come in here and refresh this page to look at what's being added. So refresh this, and since we haven't, if you head on to your Compass and refresh your cluster, you actually won't see this database shown up yet because we haven't actually called this connectDB function, which will make our REST API database. That only happens when you hit a route. But you can live refresh here, and then the database will show up and you can look at its data. But I will be looking at the data inside the database in here. So I'll add my data source. I will add MongoDB. I will copy the connection string. So I'll copy this connection string. I'll paste it right here. I'll apply, I'll OK, and I will connect to this database. I can close up my console. And you can see that it has successfully connected. Right now, there is one database named TaskDB, and there's admin local sample amplix, but the DB that we need, which is REST API, has not been created yet. So we'll take a close look at that too. So when we send this response, so I'll send this response by clicking run all requests in file. If you're on Thunder client, just click the send button. So I'll send this request. So it says connection refused on localhost port 3000. So let's check our port once again. It's actually 3001. So we have to change this to 3001. All right, now I'll just restart our server right here. And the task API is now running. So we've constructed our output. Actually, we've constructed our request. So this is our request body. This is the content type. This is the post to the route. And we can simply execute this by clicking on the button on the top here, run all requests. And we get cannot read properties of undefined. So it seems like something is returning undefined. Let's backtrack our logic right here. In our post route, it's likely that the thing that's returning undefined is request.body, or maybe our database itself is returning undefined. Let's check our database connection. So we're creating a new client and connecting using this process env. Let's check this variable name if it's correct. Go to your env file. We have Mongo URI and we have MongoDB URI. So let's rename that to be correct. Let's go to our terminal. Let's restart our server and let's hit that route again. It takes some time, but it says cannot destructure property as it is undefined. This is a simple fix. So simply come into your server.js and we have to actually make our API listen to application JSON content. So simply copy paste this code. So it makes your app use JSON and URL encoded for text data. And that should be the fix for that. If we restart our server and now for the final time send this request, we should get that this request has been created. So we do get our response 201, which is the response that we'd like, our inserted ID with the object ID of MongoDB. That works great. Now next, after creating this task, I want to get all the tasks that we have. But before that, let's look at our database. Let's look at our database structure. So I'll click on our database right here. Actually, let me rename this. So learn MongoDB. And let me select my database. So I can refresh this to reconnect to my database. And my REST API DB is now showing. So let me select my REST API DB to connect to it. I'm connected to it. So you can do the same in MongoDB Compass by simply just refreshing this. So show REST API right here. And let me open my REST API, my collections, and let me open the task table. So inside my task table, I should have exactly one row, and I do. Completed false by default, that's right. I'll create that priority and my title, right as I gave. So the next thing that I want to do is get all of the tasks. Obviously, I can open the database and see all the tasks, but inside my file itself, I have a get route to see all of the tasks that I have. So for a get route, I don't really need a body, and I can simply just send a get request to that URL. So instead of deleting that, I'll remove all of the previous runs. I'll copy this, I'll paste it, and instead of create a task, I'll write get all tasks. And for this, we don't need a body or a content type because we're not sending any information. We're simply just conducting a get request. So let's run this. So the first thing that we get is ran everything. So we actually don't want that. We just want to run this get request. So in our get request, what did we get? We got two things. So since we made that task API twice, so we got it twice, let's remove the faulty one. Let's refresh our database connection right here. And let's take 2. And let's delete this row and push it. So let's delete that row. Now let's send this get request again. Once you send the get request again, right here, you can see that we got a response of 200 and we got that task. So the task that we selected, all of them. So all of the tasks right now. Since there's only one task right here, we only got one task. So if you refresh this, you can see only one task inside the database. If you're finding it difficult to follow this, simply just go to your MongoDB Compass and refresh this, open up your REST API, your task, and you can see that there's only one task in here. The next thing that we do, so getting a task by ID. So before actually doing that, let me create another task. So the first task that we created was this, build task API. Next task is finish the UI. and the priority is, let's say, medium. So if you run this post request, it should say 201 successfully created. And inside our task DB right now, you should see that we have our medium, finish the UI. And even inside your Compass, you can see that you have that second document added right here. So what if I want to select this build a task API using its object ID? So simply, I'm going to copy its object ID right here, and I'm going to do a GET request. So for that, I'm going to do a quote, and I'm going to get one task. And in get one task, I'll send a GET request to http localhost 3001/tasks/ and not completed. So I want to complete it. So first of all, I need to send in a content type of application JSON. And the body that I will send is completed, and set it to true. Currently, if I refresh this, both of my completed are false, but since I copied the finish the UI ID right here, and I'm pasting that ID, I'm going to say that I want to change it to completed true. If I run this, I should get modified count 1. So one of my documents have been modified. Now, if I check my database again, so if I refresh my database, you can see that it has been completed true. If I also run a GET request right here, inside my GET request also, I can see that finish the UI has been marked as completed. I can again mark it as false by simply changing this to false and sending that request again. Lastly, we're going to check our deleting tasks. So delete task. By deleting the task, so we're going to send a delete request to this same task. So currently we have two tasks. One is our finish the UI and build a task API. I want to delete this finish the UI. So I passed in its task ID, and that's all we need to do. We don't really need to pass in an application JSON content type. Simply execute this and you should get deleted count 1. So one of your tasks have been deleted. If you go back to your task and refresh it, you can see that you just have one task. And instead of going back and forth to your database right here, if you're using VS Code, you would go back and forth in your Mongo Compass. So inside your Compass, you could go to your task and you can refresh this and see that only one task remains. So that was all of the endpoints. Pull, create, read, update, and delete a real database that's a complete functional API. From here on, you'll add Mongoose for schema validation, JWT authentication, error handling middleware, and environment-specific configs, but MongoDB fundamentals you just built, they don't change. You've learned everything to do with the fundamentals of creating, reading, updating, and deleting data inside MongoDB. Alright, here's what you covered in this video. You understand what MongoDB is and why it exists. You understand the full structural hierarchy, starting from cluster, then database, then collection, then documents, then fields inside that document. You know how it differs from SQL and when each makes sense. You can manage your database visually in Compass, from the CLI in mongosh, and inside your IDE with DataGrip or WebStorm. You've connected to it using Node.js and built a complete REST API with all 5 CRUD endpoints. Well, the natural next steps from here are Mongoose, which adds schema models and validation on top of what you've learned. But those are all for future videos. But with what you have right now, you can build real application, real things. Now go build something.